Hello everyone. In this video we're going to look at some exam questions together on similarity, and then I want you to have a go at the questions which are attached to this piece of homework. But just remember please, I want you to do the questions and I want you to mark it and then submit it to me please, okay? And this one is the third lesson of the week and it needs to be submitted so I can see what you're doing. Please don't just copy the answers. You know, if you're struggling, email me, but don't just copy the answers. Do try and do it yourself. If you do everything, great. If you just do like, I don't know, half the questions but you get them all right, I don't mind as long as you're having a go at these tasks, please, okay? But please remember to mark it. Okay, let's not waste any time. Let's go into the questions. Okay, so this question here, I've deleted some information about it, but basically both shapes are regular hexagons, so all the angles in the corners are the same. So they're regular hexagons, right? So what you could do now is you could pause the video, see if you can do the question yourself, and then unpause the video and see if you get the same answer as me. So pause the video now. Okay, so this is the step-by-step working out. Okay, so first of all, I would do a quick little kind of sketch of both shapes separately, just to make it easier to work things out. Okay, so here's they're terribly drawn, but that's what they are. I think the most important line is this one here, and also this one here, but it tells us that O to F, so this distance here, so let me do on here, O to F, is equal to 3 lots of O to A. So this is O to A. But basically that is telling us the scale factor from this little one to the large one. All the lengths on the smaller triangle are multiplied by 3. So the lengths are all multiplied by 3 to get from the small one to the big one. That means the area must be multiplied by 3 squared. Because remember that table from last lesson, that's how it works. If you know the scale factor for the lengths, the areas have been multiplied by 3 squared. So the area of the smaller one, that's what it means by here, OA, B, C, D, E. So OA, B, C, D, E. That's got an area of 4. So that means the area of the large one is multiplied by 3 squared. So 4 times 3 squared. 3 squared is 9. So that's 36 centimeters squared. That's the area of the larger hexagon. But that is not the final answer. The question wants you to work out the area of the shaded region. So this shaded bit. You've just worked out the area of the whole thing is 36. But the area of the shaded bit would be 36 take away the area of this section here. So take away 4. So that's 32 centimeters squared. So that is the actual area of the shaded bit. It's 32 centimeters squared. It's a bit of a devious question, but you know, it's kind of like these little things you've got to watch out for. So just make sure you read the question carefully. But if you got 36, well done. But then the final answer is 32, and I hope you got that as well. Okay, let's look at the next question now. Okay, slightly harder problem. Okay, and you're just going to need to imagine that these two shapes are 3D cones. And they tell us that they are mathematically similar. So you see that word? That means this is a scale factor problem. Now, they tell us that the volume of A and the volume of B is in a ratio of 27 to 8. Now, I'm going to let you figure this out in a moment on your own. The surface area of the larger cone is 297 and the smaller one is 132 centimeters squared. Right, see if you can do the problem yourself. So pause the video, have a go. Okay, so this is the work solutions. I'm going to start with this 27 to 8. Now that's the ratio of the volumes. We don't actually know what the volumes are, but it doesn't really matter. Because remember how ratios work? They work a bit like, well, they are connected to fractions, aren't they? But what I'm going to do is I'm going to divide both sides of this ratio by 8. So I'm going to divide that side by 8. So that's going to give us 1. And then this side by 8. So 27 divided by 8 is 3.375. Now, what this is telling us is that the ratio of the volumes is now 1 to 3.375. That means if this thing had a volume of 1 centimeter cubed, then this one's got to have a volume of 3.375 centimeters cubed. And that's kind of like how it works. But really, that number there is the scale factor actually, because Well, it is. It's the scale factor because the ratio is 1 to something, so this must be the scale factor, 3.375. So we now know the scale factor for the volume. Okay, so the volume for the scale factor is 3.375, but we're looking at area, so we need to find the scale factor for the area. So we need to work backwards. So first of all, we're going to find the length scale factor. And remember, if we know the volume one, we've got to cube root it to get that one. Okay, so the cube root of that, please be a nice number. Okay, it's not. Did I write down the... Yeah, 3.375, and then the cube root of that is... Oh, it is a nice number. It's 1.5. So all the length, so all the edges were multiplied by 1.5. That means the surface area, or I'm just going to put area, would have been multiplied by 1.5 squared. Okay, now just to remember the direction. So we are told, oh, so we have to show that the area of the smaller one is 132. So the area is 297 centimeters squared for the larger one. But if we take 297 and divide it, because we're going the other way, we're going from the big to the small. If we divide it by 1.5 squared, so let's do that, 297 divided by 1.5 squared, lo and behold, is 132 centimeters squared, which is what the surface area of the smaller one would be. So we've just shown that the surface area of the smaller one is 132. There are different ways to do this question because it's a show that question. So you could have done 297 divided by 132, which equals 1.5 squared by that way, or there's other ways to do it, but that's one way to do it as well. Okay, so I hope you understand that one. Now, the last question. This is the toughest one of all. And let me read it to you first of all and try and underline some key things. So a person is going to make a clay model. Now, okay, let me read it. Mark as a clay model. He will now make a clay statue, which is mathematically similar to the model. So let's say this is the little clay model, and then he's going to make a giant statue from it. Okay, so this is the statue, so this is the smaller one, this is the bigger one, and they are similar, so there's that key word. The model has a base of 6 centimeters squared, so imagine this model is on a base, and that's going to be 6 centimeters squared, and the larger one's going to have a similar base, and the base of that one is 253.5 centimeters squared. Now, to make the little model, he uses 2 kilograms of clay, and basically how much clay is needed for the larger one, that's what you need to work out first. Then it says clay is sold in bags of 10 kilograms, so how many bags will he need to make the larger one? Okay, so what I would do first of all is 2 kilograms is the mass or the weight of the clay model. So how much is the weight of the larger one going to be? That's what you need to work out first. And then effectively you just need to divide that by 10 to work out how many bags to buy. Okay, so have a go at that now. So pause the video, have a go. Okay, so this is the work solutions. So first of all, I'm going to look at the bases. So these are kind of like, let's just pretend they're circular discs or whatever. This is the thing that the statue is going to stand on. So this one's got an area of 6 centimeters squared. Now, the clue is in the word area. And this one's got 253.5 centimeters squared. So first of all, I'm going to work out the scale factor for the area. So I'm going to do the big one divided by the small one. So 253.5 divided by 6 is 42.25. So that's what the area was multiplied by. Now, let's just do length. We know the area one, volume. So the lengths would have been multiplied by the square root of that. Okay, so we know the middle one. So we need to square root to work out the length one. So square root of that is 6.5. So that's what all the lengths were measured by. Now, this is where it gets a bit confusing. You need to think about 2 kilograms and how is it connected to the model? Well, the 2 kilograms is kind of proportional to the volume of the object. If you think about it, if you make a little kind of cube that weighs 2 kilograms, then if you scale the cube up, it's going to weigh more, isn't it? But the proportional factor is connected to the volume, isn't it? So the bigger the shape, the bigger the volume, the bigger the weight. So that 2 kilograms, you can think about it as a volume in that sense. So what you want to do is you want to work out the scale factor for the volume, which would be 6.5 cubed. So how much clay is needed for the larger one is really simple, because you take the weight of the smaller one, the 2 kilograms, and you just multiply it by 6.5 cubed, because that 2 kilograms is connected to the volume of the object. The bigger the volume, the bigger the mass, the bigger the weight. So that you can treat it as just the volume itself if you think about it in a logical way. So the amount of clay needed to make the larger one, we just need to take 2 and multiply it by 6.5 cubed, which is a lot. So that's 549.25 kilograms. So I hope you got that. So that's how much clay is needed to make the larger model. But that's not what the question's asking. The question's asking is how many bags is the person going to need to buy? So let me clear some of this annotation. Okay, so in order to work out how many bags they're going to buy, you're going to need to take the 549.25 and divide it by 10, because they come in bags of 10 kilograms, and that's how many kilograms the clay model, the clay statue is going to need. So dividing that by 10 roughly equals 54.925. So you can't buy point something of a bag, so you're going to need to buy 55 bags, aren't you? So that is how many bags you're going to need to buy of clay, and I hope you kind of got that as your final answer. So that was the answer to that one. So the only tricky thing about that is you needed to think about that as a volume. Okay, so the kilogram is kind of connected to the size of the object. So the size of the object is its volume, because if you think about it, the clay is going to make the entire shape, the inside and the surface. So it's kind of connected to the volume. So you just treat that as a volume. You multiply it by 6.5 cube. That tells you kind of how much clay you need for the larger one. And because bags comes in size of 10 kilograms, you kind of just need to divide that by 10. But you can't buy 54.9 bags, so you're going to have to buy 55. And that's the answer. And I hope you kind of got that. So now it's time for you to have a go at those exam questions and see if you get them right. And then please mark them as you're going along, and then submit those answers to me for checking. And thank you very much, guys. And let me know if you're having any problems. Some of you have been emailing me, but it'd be nice to kind of get an email from you to see how you're getting on. But thank you for watching, guys. I'll see some of you next week. I'm so excited to be back in school. I don't know about you, but I'm really, really looking forward to it. So I'm hoping to see some of you guys, especially my form. You know, I do miss having our form time and my 2 enrichment classes. I do miss teaching you guys. So looking forward to seeing some of you guys next week. And stay safe. Bye, everyone.